And then this device is actually interesting because even though you have a wall here, it's basically supported. So it is basically untippable. And then these legs can be deployed fully.
Right-hand side is without reinforcement learning, and left-hand side is with reinforcement learning. At the top, you want to go faster, and at the bottom, you want to go slower. So this adaptation happens, again, between 12 to 25 seconds.
We have a system that's able to calculate the pathway that we want the subject to walk. And then we create a kind of virtual trail.
The displacement of our center of mass has significantly reduced for more than 10% after only one training section.
Three one are real patients. For example, the patient with scoliosis, the patient with right leg ligament strain.
And in case we wanted to steer the patient one way or another, since the walker is supposed to be passive, we just brake the wheels selectively.
So what we want to do is to generate robotic hoists that can do also personalized assistance to do sit to stand.
In the case 2, we also used the device in 40 sessions, and also we could verify gait speed and cadence improvement.